I would like you to imagine introducing yourself to a child, a peer, and an elder. Maybe your vocabulary changes from hi to hello to good evening. Maybe your tone changes from hey to hey. Maybe even your posture changes. In humans, we sometimes refer to changing our behavior to match our perceived social environment as code switching. But examples of this flexible behavior exist across the animal kingdom. In my thesis, I focused on the neuroscience of how one animal, the zebra finch, recognizes its social environment and makes split-second decisions on what type of song to sing. Now, the zebra finch and us humans each have specialized collections of brain regions for vocalizing and for socializing. And in my thesis, I hypothesized that these vocal and social brain networks must be talking to each other to facilitate this code-switching-like behavior that we see. So, with some of my early thesis work, I actually found a physical connection between this vocal and social network in the songbird brain. By using a fluorescent dye, I was able to see that neurons in 3 regions of this social network physically reach out and grab onto neurons in that vocal control network. But physical connections in the brain are a lot like roads. There are roads all over the world, but if you only need to pick up a few groceries, you really only have to use those few roads that take you from your house to the supermarket. So, in the next portion of my thesis, I tried to narrow down things and figure out which of these roads in the songbird brain they're actually using for this code-switching behavior. Now, since this behavior is very driven by social experiences, I thought that maybe a social hormone like oxytocin might play a major role. So, to test this, I gave zebra finches a drug that blocks oxytocin signaling in the brain. While under the influence of this drug, zebra finches failed to make the characteristic changes to their song that we would expect when they sing in one context versus another. And this gave us some preliminary data to say that it could really be these oxytocin-powered roads between the vocal and social networks in the songbird brain that are allowing them to make these code-switching-like behaviors and change their song. Now, I know you may be sitting there and thinking, this is a lot about birds, but we're humans. What's going on? I'm here to tell you that these songbirds actually learn to sing incredibly similar to how we learn to speak. So my research actually gives us some critical insight into what could be happening in the human brain when we are experiencing kind of social disorders where our behavior is disrupted in a social environment, like what you see with anxiety. So to put that into context, I want you to imagine kind of singing in your shower and then maybe replacing me up here at this mic and singing for this audience. While your vocal ability doesn't change based on where you are, your vocal performance will likely have some major differences there. That same exact thing is happening to these birds, and that's what makes them an excellent model for us to learn a little bit more about ourselves. So, the next time you're trying to decide between saying hey and hey to someone you're meeting for the first time, know that a zebra finch somewhere might be making that same exact decision. Thank you.